Hi guys, today we're going to do a review video over Unit 5, which was our geometry unit. In this video, we're going to have questions that cover all the different topics from our geometry unit to help prepare you for that unit test. So first, let's look at our angle pairs. We have 3 questions here. Using this graphic, we need to identify a set of vertical angles, adjacent angles, and linear angles. All right, remember with vertical angles, they create, if your angles are twisted, they're not always vertical. But the thing that I use to remember them is they kind of form an X and they're across from each other. So depending on how you look at it, they are vertically stacked. So if we look at this diagram here, I see that this angle and this angle match that requirement. So it forms that X and they are across from each other. Meaning that if we're going to properly name this, you can start in either direction. Typically, we go in alphabetical order. So I'm going to start down here with E. So EGF. So angle EGF is congruent to CGD. Apparently, I have really sloppy handwriting today. Clearly, it's been a minute. Just as a little extra bonus, remember with those vertical angles, they are congruent, and congruent is another word for equal. So let's just say that our first angle was 70 degrees, then our second angle that is vertical to it would also be 70 degrees. They are congruent, they are equal. All right, now we need to find a pair of adjacent angles. Adjacent angles means that they share a vertex, so that's a corner point, and they share a side. So typically, an easier way to kind of think of that is they're next to each other. So there are actually several adjacent angles that we can see here. These two would be adjacent. And then this one would be adjacent to here, and then that would be adjacent to this one. That would be adjacent to this one. And then that would be adjacent to this large one down here. So technically, we could pick any two of these, and we would have a pair of adjacent angles. So I'm just going to select two of them that don't have any markings yet on them. So let's go ahead and pick AGB. So angle AGB, and we could either say it is adjacent to BGC, or we could do AGF, because in both cases, they share that vertex and they share a side, meaning they're adjacent, they're next to each other. Let's go ahead and do BGC. And last but not least, we need to find a pair of linear angles. So linear angles, remember, they create a straight line. So we need to find a set of angles that are going to create a straight line. Because it says the word pair, that tells me I need two angles. That kind of minimizes my choices here. And if we look down below, that would be these two angles right here, because they come together to form this straight line. So that would be a set of linear angles, which would be, for our naming purposes, EGF and DGE. And those are a linear pair because they're next to each other and they come together to make that straight line, which means if they're a linear pair, they're also what we know and refer to as supplementary angles. Those are kind of used, interchangeably. All right, we're going to continue working with angle pairs, only now we're going to use that knowledge and we are going to find all of our missing angles here. So first thing I always do is look at the information I'm given, and then I treat it kind of like a puzzle, and I might not find number one first. I might have to say, okay, this is what I'm given. What is a matching angle pair here? And when I look at this, honestly, I see a couple different ways that I can start. The first thing that pops into my mind is I notice that this known angle, which is 37 degrees, is vertical angles with number 2. So if those two angles are vertical, that means they're congruent. And if they are congruent, they are equal, which means the measure of angle 2 would also be 37 degrees. I always write this information down in my picture because it's, again, I kind of think of it like a puzzle, whether it's like a logic puzzle or, a physical puzzle where as we slowly put those pieces together, we need to make sure we connect them so that way we can see the bigger picture. We can start to make more connections. We can build on that. The next thing I notice is that if I go back to the angle that I was originally given, this 37 degrees right here, that angle and angle 3 form a linear pair. And remember, we said a linear pair means they form a straight line. So they come together, they form this straight line, meaning they equal 180 degrees. So if together these two angles, so 37 degrees and angle 3, if together they equal 180 degrees, what can we do to find the actual measurement of angle 3? Well, we can subtract. We can take that 180 and subtract 37, telling us that the measure, of angle 3 is 143 degrees, because that's what's needed to make those linear, to make it equal 180. All right, last but not least, we have number 1 up here. Well, I don't see any relationship between that 37 degrees and the 1. So I'm going to have to start looking other places. I do notice that this right here is telling us that that is 90 degrees. Well, there's a couple different ways that you can look at this. One way is noticing that then the other side would also be a right angle, and it would also be 90 degrees. So that is broken down into angle 1 and angle 2. So we know that angle 1 plus angle 2, which is 37 degrees, would come together and make a right angle of 90 degrees. What can we do there to then find our missing piece? We can subtract. 90 minus 37 would be 53 degrees. And we have found all of our missing angles. So we just kind of took it one piece at a time. Everything was labeled. We didn't end up needing, to use, well, actually, no, we just did. We had to use the measure of angle 2 to find the measure of angle 1. So that's the benefit of labeling your picture, is that makes it just a little bit easier to make those connections than having to look back and forth. So just a tip. All right, we're going to move on to circles, and we're going to start off with our circumference of circles. And I'm going to move my camera to the other side here so you guys can see those formulas. So remember, you have two different formulas for the circumference of a circle. You can either just use one of them, or you can use them interchangeably. But the first one here, 2 pi r, is when you're given the radius, and then the second one, pi d, is when you're given the diameter. So if we look at our question here, that's what we need to first identify. Are we given the radius or are we given the diameter? And we are given the radius, and I know that because it is from the edge to the center. It only goes halfway, and that even matches our picture here. So the radius is halfway, the diameter is all the way across. And our directions tell us to use 3.14 for pi. Always pay attention to that, because sometimes you'll use that for pi, other times you'll be asked to give the exact answer, and you just need to leave it as the symbol for pi instead. So always read those directions carefully. So the formula that we'll use is c equals 2 pi r. Since we're given the radius, now we're going to plug in, we're going to substitute all of our information. Well, we don't know what the circumference is, so we'll keep that as c. Then we have the number 2 times pi, and we were told that we're going to use 3.14 for pi. And then that's being multiplied by our radius, which is 4.5. This is all just straight up multiplication. So at this point, you can either, multiply on paper, or you do have permission to use a calculator, and you can just take 2 times 3.14 times 4.5, and we get a circumference of 28.26 meters. When you are asked to find area, instead of that being the measure of the outside, like circumference is, area is the measure of the inside. So we do have a different formula. But the beauty is, once you learn how to use formulas, it doesn't matter what formula it is. That process is the same, where you find the right formula, identify your information, substitute that in, and solve. So I personally really like formulas for that reason. So our formula for the area of a circle is the area is equal to pi times radius squared. So now let's read our problem here and identify the information that we were given. So we're told that it has a radius of 34.1 inches, and we are being asked to use 3.14 for pi. Well, that's all I really need. So let's substitute and solve. So A is going to stay in A because we don't know the area. That is our question. That's what we're being asked to find. And that is equal to pi, which we're using 3.14. And that's multiplied by our radius of 34.1 squared. Now here we do have multiplication and exponents, so we need to follow the order of operations and do our exponents first. So 34.1 squared, that's another way of saying 34.1 is being multiplied by itself 2 times. When we do that, we do have a very large number here, 1,162.81. And then thankfully, if you used a calculator, you can just keep that in there and hit multiply by 3.14. And we get the very large area of 3,651.2234. Now, these directions didn't tell us to estimate and round our answer. Typically, it'll ask you to round to the nearest hundredth, maybe the nearest nth. Let's just go ahead and round it to the nearest hundredth. So remember, the nearest hundredth, there's 2 zeros in that, meaning we only need 2 decimal places. So you're going to look at the third number, though, to tell you whether you round that up or down. And since 3 is less than 5, we're going to round our number down. So it would just stay 0.22, and then our label, let's see, we're working in inches, so it would be inches squared. Switching up shapes again, we're going to our triangles here. When we work with triangles, there were several different theorems that we learned. This one right here is the exterior angle theorem. And notice that there's a little diagram in the picture here to remind you of what that theorem is. But if we take our spotlight here, that tells us that if we know the two remote interior angles, or even if we don't know them, the two remote interior angles, the sum of them, when I add them up, that is equal to the measurement of an exterior angle. So if we look at our question here, we are in fact given the two remote interior angles, and they're interior because they're inside the triangle. And we are being asked to find that exterior angle. So we can easily do that by following our formula and knowing that if I add those two together, it will equal the same measurement as the exterior angle. So 70 plus 50 would give us 120 degrees for the measure of our missing exterior angle. Now let's talk about the triangle inequality theorem. This has to do with the side lengths of the triangle. And if we look at our little reminder graphic up here, it's telling us that the sum, so the addition of any two sides of a triangle, have to be greater than the length of the third side. And because it says any two sides, whenever you're using this theorem, whenever you're trying to figure out, can these three side lengths actually come together and close and form a triangle, you have to test it 3 times. You have to do all 3 possibilities. So I like to do it the same each time because then I make sure I don't miss anything. I first add the first 2 together. So we need these 2 sides to be greater than the third side of 2. And 6 plus 3 is 9. 9 is definitely, greater than 2. So that checks out. Then the next thing I do is I add the last 2 together. So these last 2 sides need to be greater than the first side of 3. Well, 6 plus 2 is 8. 8 is greater than 3, so that checks out. And then the last one I do is I take my 2 ends. So we need 3 plus 2 to be greater than 6. Well, 3 plus 2 is 5, and is 5 greater than 6? No, it's not, which means these 3 side lengths would not come together and form a triangle. These could not be the measurements of a triangle because any 2 sides, so all 3 different tests that we do, have to work and have to be a yes in order for our overall answer to also be a yes. So your triangle, may look something like this, where one of the sides isn't quite long enough to reach and form a true closed-in triangle. Now we have the triangle sum theorem. The triangle sum theorem focuses on the interior angles, so the inside angles of a triangle, and it says that if you have 3 angles together and they form a triangle, that means they are going to add up to equal 180 degrees. So looking at our diagram here, we know that one angle is 96 degrees, one is 21, and we want to find the measure of this missing angle. Well, because it's a triangle, all 3 of these together are going to equal 180 degrees. So we can add up the 2 angles that we know. So 96 and 21 means we currently have 117 degrees. But in order to get our triangle to find this missing angle, it needs to be 180. So we can take that and subtract it from 180, discovering that the measure of angle X has to then be 63 degrees. And if you ever wanted to double check your work, a quick way to double check is add these three back together. So add 63 plus 96 plus 21, and you should get 180. If you did, your math is right. If you didn't, there was a mistake somewhere. Next up is polygons. So we want to know what is the measure of the interior angles of a regular hexagon. So if we look here, remember that when we taught this, at the beginning, if you wanted to, do some memorizing of, the measurements, you could. The triangle one is super easy to remember. It's 180 degrees. But as we get bigger, I don't know, for me, that's not something I find important to memorize. So therefore, I just like to learn the formula, and then I know I can use that for any shape to quickly find the interior angle. That just works better for me. So our formula for that, if you don't have this in your notebooks, make sure you add it, is n, where n is the number of sides, minus 2, and then you multiply that by 180, and that will give us the sum of the interior angles. So if we have a hexagon, how many sides does a hexagon have? A hexagon has 6 sides. So that means in our formula, n is equal to 6. So you might be able to do this without officially using the formula, but I always like to, write it out for you guys. So n minus 2 means we're going to take 6 minus 2. Ooh, yikes, I've got a little lag there on my parentheses, times 180. So 6 minus 2 is 4. 4 times 180 is 720. So the interior angles of a regular hexagon would add up to equal 720 degrees. All right, last but not least, we got a couple questions on cylinders here. So first off, let's review the volume of cylinders. So we look at our little graphic here. We are not only reminded of the parts, but we also have our formula. So very similar to circles, we have a formula, or even the polygon question we just did. If we know the formula, we just have to identify our information and then substitute, so AKA plug it in and solve. When I look at my question here, we want to know the exact volume of a cylinder. So that's important to note. And I can see here that it has a height, even though it's sideways, that's the height, that's how tall it is, of 26.9 inches. And then right here in the base, so the circle part of our cylinder, our radius is notated for us. We have a radius of 21.4 inches. So if our formula is V is equal to pi r squared h. If we're being asked to find the exact volume, that means we're not going to estimate the value of pi. We're not going to be using 3.14. We're going to be keeping that symbol for pi in our entire problem and in our answer. So the V stays the same because that's what we're being asked to find. And then because we want the exact volume, we just leave that as the symbol for pi. And then it's being multiplied by our radius squared. So 21.4 inches squared. And then that's being multiplied by our height of 26.9. We need to follow order of operations, telling us to do the exponents first. So 21.4 squared would give us 457.96. And then notice that I'm copying all my other work down. Now we need to do the multiplication. Well, since we want the exact volume, we can't really multiply by pi. So we're just going to multiply our two numbers here together. So 457.96 times 26.9. And then the standard way that we write an answer is the number first and then the pi after. It's not a variable, but since it's still a symbol, it typically comes second. So I'm going to rearrange this a little bit. So that volume would be 12,319.124 times pi. And since it wants the exact volume, I'm not even going to round this right here to the nearest 10th or 100th because it wants it to be as exact as possible. And since it's volume, we would have inches cubed, and that would actually be it. That would be our answer representing the exact volume of this cylinder. Our final question is on the surface area of a cylinder. So this formula is a little bit longer, but it's written right here for you, and it should also be in your notebooks. So if we read our directions, we want to find the surface area of the cylinder. And this time we are using 3.14 for pi, and we're being told to round our answer to the nearest hundredth. So if we go through and label our information, I'm actually going to change some of these markings so we can color code it since our formula up here is color coded. We're using 3.14 for pi. We have a height of 10 feet, and we have a radius of 16.3 feet. So now let's just plug all of that in to our formula. Our formula is right here. We are being asked to find the surface area, so that stays SA for surface area, and that's multiplied, and then we have 2 times pi, which is 3.14, times our radius, which is 16.3, and then times our height, which is 10. And that is going to be added to 2 times our pi again, so 3.14, and then times our radius squared. All right, because we have this plus sign here, and then we have, all multiplication and exponents, which is, a form of multiplication, we can simplify the two pieces kind of simultaneously, and then we can add them together. So for this first group here, this is all pure multiplication, so we can just type that in our calculator. 2 times 3.14 times 16.3 times 10, which gives us 1,023.64. Then for our other side here, we know that we need to do exponents first. So we're going to take 16.3 and we're going to square that. And then that answer, which is 265.69, is multiplied by 3.14 and multiplied by 2. And that gives us 1,668.5332. And I'm going to wait until the very end to round my answer. That's typically best practice because then it prevents you having any rounding error, and it's not like we're dealing with money, or anything like that. So we're going to add these two very large numbers together. And prior to rounding, that gives us 2,692.1732. Whew. We were told in our directions to round to the nearest hundredth. So that means I need 2 decimal places. So you look at the number right after that to identify how you round. Since 3 is less than 5, we're going to round down, meaning it would just be 2,962.17. And with surface area, that would be feet squared as our final answer. All right, hopefully you found this video review helpful. It maybe freshened things up in your mind, gave you those formulas. Make sure you use the formulas when you take your test. That is something you're allowed to use, as well as a calculator. So use those tools to make sure when you're working with these large numbers here that you don't make a mistake. All right, if you need anything, as always, reach out to your teacher and we'll be happy to help, or go to a help session. Bye.